Hello everyone. In the last video, we saw solar power. Here in this video, we are going to see the working of solar cell. A solar cell is an electrical device which converts light energy into electrical energy. It is basically a PN junction semiconductor device which works on the principle of photovoltaic effect. We know that a semiconductor have the conductivity between insulator and conductor. Commonly used semiconducting materials are silicon, gallium arsenide and cadmium telluride. A semiconductor does not conduct on its own. We need to improve the conductivity. So in order to improve the conductivity, we have to add some impurity to the pure semiconducting material. The process of adding impurity to the semiconducting material is called as doping. Here I am considering the example silicon. Silicon has 4 valence electrons. So inside the material, the atoms are perfectly bonded. So there are no free electrons in the material. So automatically there is no conduction inside the material. So in order to increase the conductivity, we need to dope the material. So how can we dope the material? Here, as I said, I am taking the silicon material in the as an example for the semiconducting material. So silicon is doped with a pentavalent atom. Say for example, phosphorus atom. So pentavalent atom means the pentavalent atom has 5 valence electrons. So these pentavalent atoms are replaced with the silicon. So we are replacing few silicon and we are putting some phosphor atom. So what happens? There are free electrons inside the material and these free electrons starts moving inside the material. So the pure semiconductor which are doped in this way, that is which are doped by the pentavalent impurity, are called as N-type semiconductor. Similarly, we can add trivalent impurity atoms to a pure silicon atom. That is, for example, we can add a boron. We can add boron impurities and what we do is like the same way we are replacing few silicon and we are putting some boron atoms. So what happens? The boron atom has 3 valence electrons. So there is a lack of electron and so we can see when they bond with the silicon atom there is a lack of electron. This lack of electron is called as holes. The holes have the charge opposite to that of electrons. So the semiconductor, the pure semiconducting material doped in this way, that is the doping of trivalent impurity to a pure semiconducting material is the materials is semiconducting material is called as P-type semiconductor because here we can see excess holes in the material. So in such a way we are getting P-type and N-type material, semiconducting material. Here what we are going to do is we are going to grow a N-type semiconducting material above a P-type semiconducting material. So as we see, the P-type have excess holes and the N-type have excess electrons. So when they are joined together, a PN junction is formed. So what happens now? The excess electrons from the N side starts diffusing to the P side. And so what happens? They recombine with the holes in the P side. So what happens near the junction? Immobile ions are created. So, near the in the N side, near the junction, positive ions are created, and similarly on the P side, we can see negative ions. So, a region is formed in the junction. That is, here we get so a region is formed at the junction and it is depleted of mobile charge carriers. So, this region is called as depletion region. So, the depletion region, there is a in the depletion region, there is a what happens? There is a electric potential difference across the depletion region, which prevents the flow of further electrons into the junction. So, this potential is called as built-in potential. Here we are not giving any external source. Now, in the case of solar cell, we give a reverse bias. So, what is reverse bias? Reverse bias means we give the p-type is connected to the negative terminal of the battery and the n-type is connected to the positive side of the battery. So, this is called reverse biasing. Now, when light falls on the N side, what happens? It reaches the PN junction. So, in the PN junction, we know that light is having the energy of the light is in the form of photons, and this photons have the sufficient energy, and in the junction they create electron hole pairs. And so, what happens? Excess electrons are created and they cross the junction. So, and they starts moving to the positive side of the battery. So, what happens? An external current starts flowing through the circuit, and this current is called as photocurrent. In a normal silicon solar cell, that is a tiny single solar cell, 0.5 to 0.6 volts of energy is created. So, this is a single cell. We are considering only a single cell. In the solar panel, there are so many cells that are connected in series and parallel, and they are taken in a combination, and so they can generate more energy. So, this solar assembly is encapsulated in a case, and above that we place a glass film, so that to avoid the mechanical shock. So, in such a way, doing these things, we can generate energy, that is the electrical energy, with the help of solar cell. Thank you.